So I've had a student working here this evening, which means I've written down answers to this lesson, but am now just putting audio over top of it. Please graph for class example 1 the graph of tan root 2 or tan 2x equals root 3 and find the exact values of x. Remember, probably the best thing to do is graph y1 as tan 2x and y2 as root 3. And then you want to find the point of intersection of those. It's interesting to look at a tan graph because it's way different than a sine graph. We haven't seen a lot of tan graphs. And it's interesting to see how many answers there are. Between 0 and 2 pi, you should actually find 4 answers where the graphs intersect. Now, why is that? The key is what's happened to period. The standard period of a tan graph used to be pi, but because of the 2, we are now at pi over 2. And my answers can all be arrived at by taking the smallest angle and simply adding pi over 2 to it. So pi over 6 plus multiples of pi over 2 will take me to the other answers. Try that out. So hopefully you had I had a chance to do that. My 7 kind of looked a little weird. It should have been 7 pi over 6. It kind of looked like a crazy 2. Sliding down and over actually. I'm going to make use of that same F substitution, except I'm going to substitute for the value of my trig ratio. So currently I'm looking at sine 2x, and x was going from 0 to 2 pi, but I'm looking at 2x. Well, if I increase to 2x, my domain is actually going to grow. So I'm going to multiply the x by 2, and I'm going to increase my domain values. I actually want to see what this graph does from 0 to 4 pi. And then I'm going to get rid of the 2x. I'm going to make my thinking a little bit easier by replacing the 2x with an f, a placeholder. It allows me to do the same operation. I'm going to treat this graph as if it had the standard period of 2 pi because I'm looking at a coefficient of 1 in front of the term. So I'm going to treat my graph as if it had a period of 2 pi, and I'm going to solve for f. Now the cool thing is I have to go way further. So when I go inverse sine of -1/2, I'm finding out that I have answers that exist in quadrant number 3 and quadrant number 4. So those answers are my first 2 answers. 11 pi over 6 and 7 pi over 6. And to that, I have to add 2 pi. So I added 2 pi to 11 pi over 6. I added 2 pi to 7 pi over 6. And I get ridiculous values of f. So f is now 4 different values, all over 6, which will be good in a minute. But I need to remember that f is actually 2x. F is actually 2x. So I need to solve for what x is. Well, in order to get x, I have to divide all these lovely red fractions by 2. And that's going to change all my denominators to 12, which looks like a fantastic operation. 11 pi over 12, 7 pi over 12, 23 pi over 12, and then 19 pi over 12. And I should find a relationship for the general solution. The general solution should be the smallest value and then adding a multiple of the period. Now I get to consider, by the time I'm looking at my actual answer, that my period is pi. So 7 pi over 12 plus n pi will help me generate all the solutions for all the real numbers. And 11 pi over 12 plus n pi will do the same thing. That's because the period is pi and the elements of the general solution differ by multiples of pi. Remember, n is an element of the reals. Now we have an interesting question coming on the flip side, dealing with a roller coaster again. But a roller coaster that has an interesting substitution problem. So here I'm taking a look at my roller coaster. So I ended up losing my recording little button thing, but we're good to go. You'll notice that the content of my cosine is not desirable. It's pi over 12 times t. I'm going to first look at it to calculate my period. So I've done that. I've gone period is 2 pi regularly on a cosine graph, divide by my b value, which is pi over 12. Which gives me 24 seconds. That's going to be really nice, but I need to deal with angles and radian measure, and that's going to be a difficulty. So what did I attempt to do? Sliding down. My record button is in a bit of a funny spot. I'll adjust that. So I'm looking at my time going from 0 to 24 seconds for one complete rotation. One complete rotation should correspond to 2 pi. So 0 to 24 on t represents 0 to 2 pi on pi over 12 times t. So I'm going to end up doing eventually the same thing with the contents of my cosine. I started with a little bit of algebra to simplify things. I subtracted the 5. 7 minus 5 is 2. Then I divided by -4, which is -1/2. And now I end up looking at a trig statement that's a little complicated, and I want to simplify my life. I want to set f equal to the contents of my cosine statement. So f is going to be equal to pi over 12 times t. And now I'm going to inverse cosine the answer and get the answers are in green for f. F is 2 pi over 3 or 4 pi over 3. In the cast rule, I'm living in quadrant number 1. No, pardon me, not quadrant number 1. I'm living in quadrant number 2 and quadrant number 3, which is 2 pi over 3 and 4 pi over 3. Drawing it in there is probably helpful. 2 pi over 3 and 4 pi over 3 are sitting in this area, quadrant number 2 and quadrant number 3. But those green statements are actually equal to the contents of what f was. So I've circled those relationships, and I'll put some nice shiny sun marks on it. I'm taking 4 pi over 3 being equal to pi over 12 times t, and I'm solving for t. The pi's cancel, which is nice. 4 times 12 divide by 3. My number is hiding underneath my clock here. There we go. That's 16. So one of the times is 16, and the other time is sitting over here. So the red marks around that circle. This one generated 16. 3 times, my pi's cancel first of all, so that's really good. And I'm going to solve for time. So pi's cancel. 12 times 2 is 24, and 24 divided by 3 is 8 seconds. Now, the period is 24 seconds. How does that impact my rotating wheel? Well, this is what's really neat about it. I repeat that height every 24 seconds. So I can take 8 and add 24. I can take 16 and add 24. And then I can keep doing that. I've got 32 and I added 24. I've got 40 and I added 24. And I get a nice sequence of numbers: 8, 16, 32, 40, 56, 64. And they have a relationship. 8 plus 24 gives me 32. 32 plus another 24 gives me 56. 16 plus 24 gives me 40. Another 24 gives me 64. But my general solution can be reported here. So we're going to need lots of practice with the contents of our cosine function being something other than 1x. So check out the assignment. We will add to our quiz work, which you did today. I hope you had fun with that. Thank you very much.